All right, so today's lesson is going to be on significant figures. But before we dive into significant figures, we need to discuss what is meant by the term accuracy and the term precision. So if I have a dartboard, and when you're playing darts, the goal is to try and get the center of the dartboard. So when I am throwing my darts, let's say all three of my darts all hit right around this same location, but not in the center. Accuracy is how likely am I to get the correct answer. Or what is expected. All right, sometimes in chemistry, it's not always about being correct, it's about what we expect. Because remember, science is always changing, and so as we gain new knowledge, we may change things as well. So it's about what is expected. Precision is how likely am I to get the same answer each time. So let's look at our dartboard. My darts all landed about in the same spot each time. So my darts were precise, but they were not accurate. All right? They were precise because they all landed in the same location each time, but not accurate because they did not land where I was aiming my darts for. Now, this is important because this leads us into significant figures. And when we use lab equipment has precision. And some lab equipment is more precise than others. When we are doing a calculation overall can never be more precise than the least precise piece of equipment used. So what that means is I can never have a final value in my calculation that has a precision higher than the least precise piece of equipment. So we have some rules. And let's take a look at what these rules are. All non-zero digits are significant. So any digits 1 through 9 are going to be non-significant. Leading zeros are never significant. So what that means, let's look right here. Where are my first non-zero digits? Right here, the 3 and the 1. Before the 3 and the 1 are zeros. These zeros are what we call a leading zero. So because they come before the whole number, we start with the whole numbers 1 through 9. So this value has two significant figures, the 3 and the 1. Sandwich zeros are significant. So my very first whole number, 1 through 9, is right here, which in this case is also a 1. So everything after that, the 0 and the 5, are significant. I started with a whole number, I ended with a whole number. Therefore, everything in between is also significant. I have 3 significant figures, 1, 2, 3. Trailing zeros. Trailing zeros really sometimes take students out. as well as leading zeros as well. Those can get tricky too. Trailing zeros are not significant when a decimal place is present. All right. Or I'm sorry, are significant. I was reading the bottom one, but I'm on the second one. All right, trailing zeros are significant when a decimal place is present. So in my example here, I started with a whole number, so that 5 is significant. Now, these zeros have been locked in by a decimal. This decimal locks these zeros in. Therefore, 5.00 has 3 significant figures. If no decimal is present, the zeros are not significant. So in my next example, the 4 is the very first whole number. These zeros are not locked in by a decimal. So in this case, 400 has, it says 2, but that is a typo. It should have 1 significant figure. So really for significant figures, it just requires practice. Practice, 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 and it will eventually make sense. So how many significant figures does 205 have? It has 1, 2, 3. The 0 is locked in by a whole number in front and behind it. So that 0 is significant. And if we wanted to do some additional practice with scientific and standard notation, we could rewrite this. So we would rewrite this 2.05 times 10. My decimal place moves to the right 2 times. And since I moved to the right, it is a positive exponent. My next example, this 0 is locked in by whole numbers and a decimal. The 9 and the 8 are always significant, right? Because remember, values 1 through 9 are always significant. This 0 is locked in. So I have 1, 2, 3 significant figures as well. Now, if I wanted to take this out of scientific notation, I'm going to move my decimal place to the left because it is a negative exponent 2 times. So when I move my decimal place to the left 2 times, I get 0.098. Now I have 3 significant figures. So I need to add this 0 in as well. This 0 is locked in by whole numbers. This 0 is not. So this first 2 zeros are what we would consider a leading 0. They are not locked in by whole numbers. This 0 is. All right, let's check out my next example. We have some leading zeros. These zeros are not locked in. There's no whole number in front of these zeros. So they cannot be significant. So we are going to start with our very first whole number, which is a 2, 1, 2. Or I guess I shouldn't say whole number, I should say non-zero digit. So my very first non-zero digit is a 2. So I have 1, 2 sig figs. And if we wanted to take this out of standard and put it into scientific notation, that's going to be 2.4 times 10. I would move my decimal place left here to get back to where I started from. So that is a negative 3 times. If the scientific and standard notation conversions is going a little too fast for you, I would encourage you to go back and review the video on scientific and standard notation. All right, this next example has no zeros. They're all non-zero digits. So 1, 2, 3, 4, 5 non-zeros, all significant. And if I wanted to put this into standard notation, it would be 0.0001387. I still have 5 significant digits, 1, 2, 3, 4, 5. These zeros are not locked in by a number 1 through 9. They're a leading, right? Because the very first number that's a non-zero comes after. 6.88 times 10 to the third. 1, 2, 3 values, all of which are non-zeros. And to take this out of scientific notation, it'd be 6880. Now I want to keep 3 significant figures here, so I'm going to just leave this 0 as is. I'm not going to put a decimal behind it, because if I put a decimal behind it, let me do this in pencil so I can erase it. If I put a decimal behind this 0, I've now locked it in. So this 0 is locked in by non-zero values and a decimal. It becomes significant. By leaving this decimal off, the 0 is a trailing 0 and not significant. All right, let's do a couple more examples. 2.5. Those are non-zero values, so those for sure are significant. Now this 0 is locked in by a whole number and a decimal. This 0 is significant. So I have 3 total significant figures, and if I take it out of scientific notation, that's going to be 2, 5, 0, 0, 0. Let me just one more 0. Okay, now in this example, there's no way for me to put this example in to significant figures with the way it is. So if I had a value, if I calculated this value on a problem that I was given in class, and I wanted to have 3 sig figs, the only way to put this value 250,000 into 3 sig figs is to put it into scientific notation. So one of my rules of thumbs here is if you are unsure if these zeros are significant or not, when in doubt, scientific it out and give me the number of numbers in that value as you would want for significant figures. For example, in this one we're working on, I've got it scientificed out. I have 3 numbers, 3 sig figs. All right, so let's look at my next example, 3500. These zeros are not locked in by a decimal. They are what we would consider a trailing 0. They are not significant. I have 2 non-zero digits here, a 3 and a 5, so I have 2 sig figs. So when I put this into scientific notation, 3.5 times 10 to the third, and my scientific notation does have 2 sig figs as well. All right, in this example, what do we notice? My first whole non-zero digit follows a decimal. So therefore, this decimal locks everything in. All 4 of these are significant. So if I wanted to put it into scientific notation, I would need to keep the zeros in to my value because they are now locked in, whole number and a decimal, so they are still significant. 3.500 times 10 to the negative 1.